So hello everyone. Before we start, I am Nasser Hasan. I'm from the Statistical Supporting Unit at the School of Education at and today I'm going to show you how to do MANOVA and MANCOVA analysis using SPSS software. So today we are going to talk about MANOVA and MANCOVA just briefly and kind of introduction before doing any analysis. And the second part of this webinar will be about performing the analysis using SPSS. So we're going to do MANOVA analysis and MANCOVA as well through SPSS. And you guys will see that the difference between them through SPSS will not be very different. So they are kind of, the way of doing the analysis is kind of the same with respect of adding the covariate to the analysis. And we will see this shortly. So just kind of an overview. So MANOVA tests whether there are statistically significant mean differences among groups on multiple dependent variables, or if we control some covariates, then we are talking about MANCOVA. So you can clearly see that MANOVA and MANCOVA both are a straightforward extension of ANOVA and ANCOVA, respectively. So in which the main effects and interaction effects of the categorical independent variables are assessed on multiple dependent variables. So the unique aspect of MANOVA and MANCOVA is that the variate, or sometimes we call it the super variable, or which is the linear combination between the dependent variables, which is referred to the y hat or y star, is optimally combines multiple dependent variables into a single value that maximizes differences across groups. In other words, so the new dependent variable, which is the super variable that we created, we will do an ANOVA for it. So basically, we create a new dependent variable, which we called earlier the variate or super variable, which is basically the linear combination of dependent variables. So then we perform a ANOVA analysis for this newly created dependent variable. So this is the basic idea about performing MANOVA, or the idea behind MANOVA and MANCOVA analyses. So the only difference between MANOVA and MANCOVA is the same as the difference between ANOVA and ANCOVA. So we will add in MANCOVA and ANCOVA, we just add and control for covariates. So this is the only difference between the two. So we have 4 different MANOVA test statistics in most MANOVA packages. It's actually the test statistics that assess the statistical significance between the groups on the independent variables. So the 4 tests are Roy's largest root and Wilks lambda, which is often it's the most oftenly used test. And we have the Pairwise criterion, and we also have the Hotelling trace test. So what to use? Sometimes if you have only one factor with 2 levels, Wilks lambda, Pairwise trace, and Hotelling's trace, and Roy's largest root are the same. The same in terms of the decision regarding whether the effect is significant or not, but not regarding the F statistic. So the F statistic could be slightly different, but the decision you will make is the same, will be the same. So whether you say that the effect is significant or not. So when the sample size decreases, sometimes you will see unequal ends, meaning that you will see unequal sample size in each group. So the assumption of homogeneity of variance, covariance matrices is usually violated. And in this case, the Pillai's criterion is the more robust test for this, and you may want to use this. And in general, so all four tests are relatively robust to violations of multivariate normality, which is not the same as the univariate normality. So we have two suggestions from these two references. So Roy's root is not robust when the homogeneity of covariance matrix assumption is untenable. And the second suggestion from the Bray and Maxwell book is when a sample size are equal, the Pillai's trace is the most robust to violations of assumptions. However, as I mentioned before, Wilks lambda is the most commonly used test, MANOVA test for the statistical significance between the groups on the IB. So this is about the MANOVA test statistics. And by the way, SPSS will give you the results based on the four tests. So don't worry about that. So let's move to the assumptions related to MANOVA. So the first assumption will be the independence of observations. The second one will be the reliability of the continuous variables in our model. The third assumption is the multivariate normality. So multivariate normality is usually assumed, but many times it's hard to assess. And by the way, SPSS cannot do this analysis. So if you are familiar with R or any other software, you may want to give it a try. So regarding the MVN, the multivariate normality, so if we talk about the univariate normality, sometimes researchers say that our variables met the univariate normality. So we will say that the univariate normality does not guarantee the multivariate normality. But if all variables meet the univariate normality requirement, then departures from multivariate normality are inconsequential. So, with larger sample size, this will not be a problem. So if you have larger sample size, you are good to go with this assumption. So the fourth assumption is about the linearity among all pairs of dependent variables. So any departure from linearity will reduce the power of the linear combination of the dependent variables, which therefore will affect the maximizing of the differences between the groups. So the idea in MANOVA is to create a linear combination of dependent variables. So if we don't have, or the assumption of the linearity is violated, then we will have a problem. The fifth assumption is about the absence of multicollinearity and singularity among the dependent variables. Therefore, with that being said, so the dependent variables should not be highly correlated with each other. So if they are highly correlated with each other, so what's the reason for adding the two variables into our model? And the last assumption is assessed through SPSS. So it's the equality of variance covariance matrices for all groups. And this should be done through boxes M test. And we want the results to be non-significant. So in this case, the non-significant result would suggest the absence of the multicollinearity and singularity, and therefore the assumption is met. So this is all about the overview of MANOVA and MANCOVA. So I think there is a question from Aya. So Aya is asking, how large is a sample size? So based on the central limit theorem, you may want to go with larger than 25 or 30. So anything above 30 should be fine, should be considered as large enough. And I hope this answered your question. You're welcome. Okay, so let's move to performing the analysis using SPSS. So first I'm going to do the MANOVA analysis and then the MANCOVA with the same data set. So I will share the link with you guys. You may find the link in the chat. So please download the data set. And I will give you a couple of minutes to download it before moving to do the analysis. And please, if you download it, just give me any sign. So you guys downloaded the data set? If yes, just give me any sign, please. Okay, it seems like everyone downloaded the data set and therefore we are ready to go. So let's open up the data set. Okay, so in this data set, you will see 5 variables. 2 of them are categorical and the other 3 are continuous. So the disability variable is the degree of disability, and we have 3 groups, 3 levels: mild, moderate, and severe. And the treat is the treatment, whether the participant is in the treatment group or the control group. And the WRAT_R and _A are the scores on reading a subtest of wide range achievement test, and the scores on arithmetic subtest of wide range achievement. And IQ as well. And we don't have to define the IQ. So basically, first, let's run the MANOVA analysis. So we will do a two-way MANOVA, two-way because we basically have two independent variables. So the disability and treatment. Okay, so we will have two research questions for main effects and one research question for the interaction effect, interaction between the two variables, the two IVs. So if we want to perform one way, we can do it with either disability or treatment. So for this, we will do the two-way. It's kind of the same procedure. So Barbara is telling me that the data file is not accessible. Does anyone face the same issue? Let me just fix this. So I will stop sharing my screen. Oh, okay. So let me figure it out, Barbara. Just hold on a second, please. Okay, so share. Okay, could you try this, Barbara, please? This should work now. I'm sorry for the inconvenience. You're welcome. Thanks for letting me know. So let's go back to this. Yeah, so we will have two research questions on main effect. So the first one is on the degree of disability. So the question will be, disregarding the treatment, the second IV, does the degree of disability affect children's reading and arithmetic scores? Because we have two dependent variables here. And moving to the second main effect, which is about the treatment or with respect to treatment. So the second research question will be, disregarding the degree of disability, which was the first IV, does the treatment affect children's reading and arithmetic scores? So this is about the main effects. And we also have a question about the interaction effect. So does the effect of treatment on children's reading and arithmetic achievement differ as a function of degree of disability? Or you may want to say, does the degree of disability affect children's reading and arithmetic achievement as a function of the treatment? So it depends really on your way of looking at the interaction effect. So let's move to the analysis using SPSS. So if you want to do the analysis through SPSS, first, let's go to Analyze. Then you want to go to the General Linear Model. Then Multivariate. So by hitting this, you will go with either MANOVA or MANCOVA. And for univariate, you will do either ANOVA or MANCOVA. So we will click on multivariate. And this window will pop up. Okay. So our independent variables are the categorical variables here. So we have the degree of disability and the treatment. So we want to highlight both of them and add them to, or move them to the fixed factors box. And our dependent variables are the scores on both reading and arithmetic tests, subtests. So we will highlight both of them and we will move them to the dependent variables box. Do you guys get this? Yes. Yes or no? Okay, great. Okay, so we will not play with the model here. So let's click on plots to add some plots if you want to visualize the things here. So you will see this sub window, the profile plots sub window, and you have two factors, the disability and the treatment factor. So let's move the disability factor in the horizontal axis first. And then you want to click on Add and make sure that you see the disability under the plots box. And we will do the same thing with the treatment factor. So we will highlight the treatment factor. We will move it to the horizontal axis. And then we want to click on Add. So we can see that we have disability and treatment factors, both are under the plots box. And then hit continue. Is everyone following me? Or I need to go slowly? Okay, thank you. So then let's move to the post hoc. So in post hoc, we can see that we have again two factors. So we want to do like further analysis if if one of the factors was significant. So for treatment, we don't really want to do any post hoc, because if there is a significant result, it will be between the two groups. So we just have two groups in the treatment factor. So it's not necessary, but if you want to add it, it's fine. So let's highlight both of them and move them to the post hoc test box, and just choose any appropriate method for doing the post hoc analysis. I will go with Tukey. and then click continue. And we are not done yet. So we will click now on EM means, the estimated marginal means, and this sub-window will pop up, and you will see 4 different things on the left side. So you want to highlight all of them and move them to the right side. And we will also click on compare mean effects and just choose the most appropriate adjustment for your analysis. I will go with the SIDAC to adjust the confidence interval. And then click on continue. Is everyone following? Before doing the last thing. Yes, okay. So let's move to the options. So in options sub-window, you will see different descriptive statistics and tests. So you may want to choose the most appropriate things you want to include in your manuscript or whatever. So usually we will go with descriptive statistics, estimates of effect sizes, and the homogeneity test to give us the results of the homogeneity tests. We don't want to play with the significance level. So click on continue. And we are ready to go. So before clicking on OK, so by doing this, we are actually performing MANOVA analysis. If we decide to add IQ as a covariate, we will move from MANOVA to MANCOVA because we are controlling for IQ, because we are adding IQ as a covariate. But we will keep this for later time. So just click on continue to run the MANOVA analysis. And you will see the output, the results from SPSS right here. So you will see many tables and numbers here. We don't really care about every table, every single table, and we will focus on, so I will go through every table, but I will say which one we should focus on. So this table, the first table, will give you the number of participants in each group. And the second table will give you the descriptive statistics for each dependent variable on different groups. So for example, for the mild degree of disability and the person who is in the treatment group, the mean scores on reading subtest is 106. And we have 3 participants here. So this is just to summarize the descriptive statistics across different groups, factors. And we will move to the third table, which is the boxes test of equality of covariance matrices. This table is very important because it's giving us, let me just show you this. So it's giving us the results of the homogeneity of covariance matrices across groups. And remember that for this test, we want the results to be not significant. So if you look at the significant row, it's 0.998. So it's not significant. And this is what we want, actually. So if you want to say that the box's value of 6.86 indicates that the homogeneity of covariance matrices across groups assumption is met or assumed. So both are fine. And this is the F value. And remember, we have 2 degrees of freedom with F, associated with F. So this is the first one, and this is the second one. And this is the p-value. So the p-value was 0.99, which is not significant. So this is about the third table. The fourth table is the results of the MANOVA, or the multivariate analysis of variance. So we can see that based on Wilks lambda, or whatever test you choose, I will go with Wilks lambda. So based on Wilks lambda, we can see that here, let me highlight this one. So we can see that this result is not, it's a significant. So meaning that the main effect for disability variable is significant on the dependent variables. And for treatment, it was significant as well. For the interaction, it was not significant. So if you want to write up this, you will say that the main effect, let me just minimize this to see where are the numbers coming from. Okay, so we remember that we have 3 research questions right here. 2 main effects and 1 interaction effect. So for the first main effect of disability, it was statistically significant based on Wilks lambda. So this is the Wilks lambda value, and this is the associated F test with the first degree of freedom and the second degree of freedom. And this is the p-value. The partial eta squared is this. So this is for the first main effect. For the second main effect of treatment, it was also statistically significant. And this is the Wilks lambda value. This is the F test value. This is the first degree of freedom. And this is the second degrees of freedom. And here is the p-value. And lastly, this is the partial eta squared. And for the interaction effect, we can clearly see that based on Wilks lambda method, or test, this is the test, this is the F value, this is the first degrees freedom, this is the second degrees freedom. The p-value suggested that the interaction effect was not statistically significant. And here is the associated partial eta squared. So this is how we interpret the main effects and the interaction effect. So any question before moving forward to the post hoc analysis? Oh, this is a very important question. The main effect is on which dependent variable? So remember that when we do MANOVA and MANCOVA analysis, we create a linear combination of dependent variable and we treat it as a one variable. So this effect is on both dependent variables, or the linear combination of the dependent variables, the variate or the supervariate. This is a very good question. I hope this answered your question. So I have another question. Creating a linear combination is the same that adding two variables in the same new variable. Oh no, basically MANOVA will deal with this. So I don't know if I get your question correct or not, but I think you are saying that, is this the same as, where is it? If we create a new variable through transform and compute, and then we say new this plus this, if this is your question, the answer is no. It's not the same way. I hope this answered your question, Francisco. Yep, you're welcome. Okay, so this is about the multivariate analysis. So we found that the disability and the treatment factors were both significant. So we may want to consider moving to the post hoc analysis. So if you guys scroll down, so this is the Levine's test for each dependent variable for the homogeneity of variance. Okay, so if you scroll down to post hoc, the first let's talk about, where is it? I'm sorry. Did we specify the post hoc? Let's move again to SPSS. Okay, because I'm missing the pairwise comparison table. Oh, sorry. Multivariate post hoc. Okay, continue. Multiple. Okay. So if we scroll down to the estimated marginal means, and let's move to the pairwise comparisons table. So we found earlier that degrees of disability were significant on both dependent variables, or the linear combination between them. So in this table, we will look at where exactly was the difference. So for the first dependent variable, we can see that for scores on reading subtest, there is a significant difference between mild degree of disability and the severe. Here is the one, the significant, and it was not significant between mild and moderate. And for the second dependent variable, we can see that there was a significant difference at 0.05 level between mild and severe. This is the one, and between moderate and severe. So this is the one at alpha level of 0.05. So this is for degrees of disability. And let's move to the treatment. Again, let's look at the pairwise comparisons. So we have only two groups. So for the first dependent variable, there is a significant difference between the two groups. And for the second dependent variable, the arithmetic subtest, there was also a significant difference between the two groups. So this is how we interpret the results, and here are the tables we need for the results. And I also added an APA style write-up for you guys in the slides. And by the way, the slides will be uploaded to the website after we are done with this. So in the API write-up, you want to specify which test you used, what was your dependent variable and independent variables. You may want to talk about the assumptions and then move to the multivariate analysis. And if you found any statistically significant results, you may want to move to the pairwise comparisons, the post hoc analysis, and show the differences, where were the differences exactly at. So any questions before moving to MANCOVA? MANCOVA, I'm sorry. Can I enlarge the screen? Yeah, sure. So this is the screen. And by the way, I will upload the slides on our website, the Statistical Supporting Unit website, and you may want to download the slides from there. Okay. So let's move to okay, so a question, there is a question. So what does the post hoc results mean? So post hoc is just following up. So if you can see, let's move to the first table. So if you can see this table, we found a statistical significant main effect for disability on the combination of the dependent variable. So in post hoc, we will follow up this result. So we want to look at where the effect was. So where is exactly the effect? So we found that the effect was between, or there was a difference between the mild and severe degrees of disability groups on reading subtest, and so on. So this is what the post hoc mean. It's just following up the original results you get from the multivariate table, multivariate test table. Oh, so the effect was between the two groups. So there was an effect between the two groups. I mean, the degree of disability affects one of the groups compared to another. So it affects the mean value, the mean scores on reading subtests between the two groups. So meaning that because of having the disability, whether it was mild, moderate, or severe, there was an effect on the scores for this group. This is how you interpret the results or look at the results. I hope this clarifies the same. Okay. So in other words, we will say that the disability, can we tell which group is most affected? So by looking at this table, you can see that there was, so this is I and this is J. So if the mean difference was positive, that means I has a larger value, larger mean value. And if it's a negative, meaning that the J group has the larger mean value. So we will talk about the mean value on reading. So let me enlarge this. So we will talk about the means on reading subtest. we say that the effect that the difference was significant between the mild and the severe group. So we can see that the mean difference here is positive, meaning that this group has a higher mean on reading subtest, higher score. I mean, higher mean score on reading than this group. So we can conclude from our understanding that the disability affects people or participants with severe degrees of disability than the mild degrees of disability with respect to the scores on reading subtest. I hope this clarifies the thing. You're welcome. So I hope this is clear now. Great. Okay, so I think we are ready to move to MANCOVA, and we will not talk about too much about MANCOVA since it's the same procedure. So for MANCOVA, we will just control for a covariate. So we want to click on Analyze again, General Linear Model, and then Multivariate. Everything is there. So the only thing we want to add is the IQ as a covariate. So we will control everything for IQ. Everything should be there. Then just click on continue. I'm sorry, okay. Okay, so the boxes M test will not be different. It will be as the same as the previous one. I mean the MANOVA. So scroll down to the multivariate test. So everything now will be in terms of after controlling for IQ. So we can see that the main effect for disability was, let me show you this, was significant based on Wilks lambda after controlling for IQ. So everything will be now after controlling for IQ as a covariate. And now the treatment effect, the treatment main effect was also significant after controlling for IQ. And the interaction remains insignificant also after controlling for IQ. So everything will be in terms of after controlling for IQ. So since we have significant main effects, we will move to them. We will move, okay, so I didn't add the tables again. Analyze. Multivariate EM means. So I want to add everything. So we want to move to the pairwise comparison table. So here, after controlling for IQ, we can see that there is a significant difference between mild and severe groups on reading subtest scores. And that's the only significant difference for the first dependent variable. For the second dependent variable, we have only one. So before controlling for IQ, we have two significant difference. The first one was between mild and severe, and the second one was between moderate and severe. But now, after controlling for IQ, the difference between moderate and severe on the arithmetic subtest scores was not significant. So this is for the degrees of disability. Let's move to the treatment. So for treatment, all of the differences were significant. So I think this is all about Mankova. So for APA write-up, you will do the same thing again, but you should say this sentence that everything was done after controlling for IQ, because we added IQ variable into our model as a covariate. So we are controlling everything for IQ. And this is the difference, the main difference between MANOVA analysis and MANCOVA. So, any questions before the end? And I hope that I covered everything and answered all of your questions and your concerns. So again, I would like to thank you for listening and choosing to attend this webinar. And we have a link for you guys. If you give us a minute to fill this survey, because it will really help us to evaluate our performance, and we will definitely take your feedback in future to perform future webinars. So this is the link, and I will stop the recording before answering any questions. So let me do this.